It all started with a seed project that was looking for a suitable place to develop. Until it found a place, Chancanab, which in Mayan means Little Sea, located on the island of Cozumel in the Mexican Caribbean. This is how Korallysis was born, with the purpose of interacting symbiotically with the marine ecosystem and taking care of the fragile balance that coral communities have. This seed is made up of conductive materials such as graphite and stainless steel, as well as other innocuous materials like ceramic, with the intention of observing how they interact with local organisms. A small electric current circulates between the graphite and the steel, which generates electrolysis, allowing the calcium carbonate dissolved in the seawater to adhere to the metallic material. In this way, the favorable conditions that corals require to inhabit the mineral-rich surface are created. In the course of 6 months, a tissue of various organisms was generated that indicated their well-being. As happened in the Sea Project, we also began to weave ourselves into a synergistic relationship with civil associations such as Oceanus and the Cozumel Parks and Museums Foundation, marine biologists and communities that have been involved in the process in different ways. After the sea sprouted, Korallysis entered a metamorphosis stage. We began an experimentation process in search of morphology for the structure, which was changing according to the technique and qualities of the materials. We used beach sand mixed with silica sand in the first tests, melting it at 3000 degrees Celsius and thus achieving a rigid material similar to fulgurites. In other tests, we used a mixture of cement and beach sand to pour it into a flexible mold with balloons. The result was a sponge-like structure with cavities. The conclusion was to create a modular structure based on the geometry of triangles to create shapes that adapt to any surface of the seabed. The design is inspired by the microstructures of some corals and sea sponges that allow corals to adhere better. Another quality is that when assembling the modules, a structural network with holes is generated, thus creating an ideal habitat for young fish, crustaceans, and other beings. We start with a metal support with the geometry of the module, and from there we model the piece in the workshop of ceramist Adria Simone. Oscar Vasquez, ceramist and designer, made the master mold. In Dolores Hidalgo, Guanajuato, a town dedicated to saddlery, we collaborated with Remigio Gutierrez and his family, who have dedicated themselves to this trade for generations and who made a special mold for the press. They found it interesting to work on a ceramic piece that does not have any utilitarian function for humans, but does for other species. In René Vázquez's workshop, the production of the modules was carried out. The result was a structure that creates an ideal habitat for the development of coral communities and is a shelter for various species. One of the important parts of KORALLYSIS is the generation of energy from the movement of water, so we experiment with different mechanisms. One of them is inspired by the cuttlefish squid. When exploring the reef, we discover that the gorgonians, or fan coral, and the penatillacea, or sea feather, develop in places with more currents. Thus, they gave us the answer to know the location and inspired us to create the new prototype. The spinal column resulted in a flexible and articulated mechanism that allows it to receive the oscillatory movement of the waves and takes advantage of the kinetic energy. An energy generator receives the movement of the crest to transform it into electricity. Said energy is stored in a harvester and the controller that administers the energy to feed the parts of the organisms that require it. We designed the ceramic segments that form the crest of the generator and make the molds with a CNC router in plaster blocks. The pieces are fixed to an articulated structure to form the ridge that transmits the movement to the generator. In a dry chamber are the dynamo and the electronic circuits. Finally, the first prototype of KORALLYSIS arrives at Chancanab, the Little Sea. KORALLYSIS seeks to join forces to protect coral reefs by proposing new forms of relationship with nature based on collaboration. The project involves the local community in the care of these devices in their marine habitat. The children were the main actors, participating in the assembly of the modular structures. We share with the public the importance of rethinking our relationship with the environment.